Okay, welcome to lesson 67 of 5th grade. It is called Using Prime Factorization to Reduce Fractions. So we're going to review for just a second and make sure that you know how to use prime factorization. Hi! So we did this in lesson 65, I believe, where we took our prime numbers and we used factor trees to find the prime factorization. So we took, for example, 25. And we saw, what two numbers equal 25? So we did a little factor tree. And we thought, well, 5 times 5 equals 25. So the prime factorization of 25 is 5 times 5, because 5 is a prime number. So I'm going to actually list the prime numbers so that we get used to using them. Prime number, what is a prime number? A prime number is a number where it only has two factors, itself and 1. So 1 is not a prime number, just for some few technical difficulties, but 2 is a prime number because the only two numbers that equal 2 when they're multiplied together is 2 times 1. 3 is a prime number because 3 times 1 are the only two numbers that are equal to 3. What else is a prime number? 4, no, because that's 4 times 1 and 2 times 2. So how about 5? 5, nothing equals 5 except 5 times 1. So the number and 1, so it's prime. What else? 6? No, 2 times 3 is 6 and 6 times 1 is 6. That's not a prime number. That's called a composite number. FYI, whatever numbers aren't prime, they're called composites. What else? How about 7? Because nothing else equals 7 besides 7 times 1. And 8? No, 2 times 4 is 8 and 8 times 1 is 8. That's more than 2. 9? Yes. 9? No, not 9, because 3 times 3 is 9 and 9 times 1 is 1. Not. So that is not a prime number. So yes, we'll just leave it there. So now on lesson 67, it's on page 356. It says we're going to reduce fractions by using prime factorization. So our first example, it says we're going to try to use prime factorization to reduce 125 over 1,000. So these are huge numbers, and we haven't done huge numbers before. We've only done smaller numbers. So I'm going to start with the top number. I'm going to start with 125. So I'm going to put my 125 here. I'm going to try to use my factor trees. What prime number do you think is going to go into 125 evenly? I'm going to look here. 2, 3, 5, 7. Well, this ends in a 5. And from previous lessons, we know that any number that ends with a 5 can be divisible by 5. So I'm going to try 5. 5 times what is 125? Well, I don't know offhand, right? So I'm going to say, well, 125 divided by 5. I'm going to figure that out. 5 goes into 12. Say 2 times. 10. 2. Bring down my 5. 5 goes into 25 how many times? 5 times 5 is 25. So 25. So 25 times 5 is 125. So since 5 is a prime number, I can't go any smaller than that. But I can go smaller here. What two numbers equal 25? 5 times 5 equals 25. And I can't go any lower because nothing else, no prime numbers or anything, equal 5. Okay? So that's it. We have 5 times 5 times 5. So instead of writing 125, I can write 5 times 5 times 5 over 1,000. But now, since we did the top part, which equals this, because 5 times 5 is 25, and 25 times 5 is 125. Now I'm going to go to my 1,000, and I'm going to do my prime factorization for 1,000. So what two numbers could equal 1,000? What prime numbers can I start with? Well, anything that ends in a 0 and a 5 is divisible by 5. So I'm going to start with 5. 5 goes into 1,000 how many times? I could do it mentally, or I could break it down and say 5 goes into 1,000 how many times? Well, 5 goes into 10, 2 times, 0. So we have 0 times, so we're going to add our two zeros. So 5 times 200 seems to be 1,000. Okay. Right, because 5 times 2 is 10 with 2 more zeros. Okay, so what else? Since 5 is the lowest I can go in a prime number, I need to see the lowest I can go for 200. What else will go into 200? What are these prime numbers? Well, it looks like it ends in a 0, so 5 is going to be able to go into it evenly again. So 5 times something. Well, 5 goes into 20. You see this? 5 goes into 20 4 times. We can do it mentally, or we can just say 5 goes into 200. How many times? Well, 5 goes into 20. I know that 5 times 4 is 20. So 4, 20, 0, bring down my 0, and 5 goes into 0 how many times? 0 times. So I know that 5 times 40. 5 times 40 is 200, but I can break this down smaller, right? 40 is a pretty big number. So how further can I go? Well, it ends in a 0 again, so I know that 5 is going to go into it. 5 times what is 40? 5 times 8 is 40. And it looks like this is as low as I can go, but I can go more here. What two numbers equal 8? Well, I know that 2 times 4 equals 8. This is as low as I can go, and look, it's a prime number. That's as low as I can go. But 4 is not a prime number, so I know it can go smaller. What two numbers equal 4? 2 times 2. And that's as low as I can go. So we got 2 times 2 times 2 times 5 times 5 times 5. So how we write that is, instead of 1,000, prime factorization of 1,000 is 3 2s and 3 5s. 2 times 2 times 2 times 5 times 5 times 5. That's really long. So erase this, but that's not our last step, because it's asking us this lesson to use prime factorization, which is what we just did, to reduce our fractions. So now, remember what we did the other lesson where we took our 5, and if there was a 5 here, we crossed it out and just canceled it out, and it was 1, because 5 over 5 is 1. And there's another 5, there's another 5, there's another 5, there's another 5. Uh-oh. So these ones right here have become, 5 over 5 has become 1. I guess I could use my times. 5 over 5 is 1. 5 over 5 is 1. Okay? But then what do we have left? We have this 2, and this 2. So 2 times 2 is what? 4. And 4 times 2 is 8. So we have 1 times 1 times 1 is 1, and 8. So it looks like our answer is 1/8. So we use prime factorization, really long process, to help us reduce our fractions to 1/8. Okay? So we're going to go on our next little example. I'm going to keep my prime numbers here so we can have a nice quick look at it. Now it says reduce 375 times 1,000. You can go ahead and pause it and see if you can do it on your own, and come back and see if your answer matches up with mine. Okay? So 375. 375. I'm going to say, well, I know 5 is going to go into it because this last digit is a 5. So 5 times what is 375? You can do it mentally, or you can take our 375 and divide it by 5. 5 is 37 how many times? 5 times 6 is 30. 5 times 7 is 35. Looks like 35 because 5 times 8 is 40, too much. 5 times 7 is 35. Minus, I know that 5 goes into 25 evenly because 5 times 5 is 25. So 75 times 5 is 375. But this is too big. I need to break this down smaller. It's not a prime number yet. So what will go into 75? Well, I know 5 goes into 75. How much does 5 go into 75? Well, I play Rummy Cube, so I know this answer mentally, but we're going to do it right here. 5 goes into 7 how many times? 1, 5, 2, bring down our 5. 5 goes into 25 how many times? 5 times 5 is 25, so 15. 15 times 5, but I see that 15 is not a prime number yet, so I have to keep going. What two numbers equal 15? Well, I know that 3 times 5 is 15, and 5 is a prime number, and 3 is a prime number, so I can't go any further. any smaller. So instead of 375, I'm going to start with the smallest number, 3. I'm going to write 3 times 5 times 5 times 5. 5 times 5 times 5. Okay? Now we've figured that out. And if you remember what 1,000 was, I think it was three 2s and 3 5s. But you can do it over again. But I know from our previous answer it was 3 2s and 3 5s. 2 times 2 times 2 times 5 times 5 times 5. So now we have done our prime factorization, but now we need to reduce. And how do we reduce? Well, we match up the numbers. There's a 5, there's a 5. So that's 1. There's a 5, and there's a 5. That's 1. 5 over 5 is 1. And then here's another 5, and here's another 5. That's 1. And then there's a 3. Okay, so that's done. 3 left. But what's under here? Is there a 3 here? No. There's a 2 here? No. Can't cross the 2s or 3s out. So we have 3, and then we have 2 times 2 times 2. Now we can just multiply it across. 1 times 1 times 1 times 1 is 1. 1 times 3 is 3. So we have 3 over 2 times 2 is 4. And 4 times 2 is 8. So our answer should be 3/8. Okay. It's a long process, but with practice you'll get it. All right. So that was example 2. It looks like you are on your own now. It looks like practice set. It says write the prime factorization of both the numerator and the denominator of each fraction, and then reduce each fraction. So exactly what we did to see if you can do it on your own. If you can't do it on your own, then go back and see if you can have any tips to make it easier for you. Okay, remember that if you want to look at the last digit of the problem and see what will go into there with your prime numbers, because if it ends in a 0 or a 5, you know that it's divisible by 5. Okay, and if it's an even number, right, then you know it's divisible by 2.